Next, property product. So before we do that, let's review our exponent properties. So we spoke about an acronym, right? So we spoke about MADSEAM. So when you multiply exponents, you add them, right? Or when you multiply powers, you add the exponents. So like x squared times x cubed is x to the fifth. When you divide, you subtract. So x to the third, x to the third over x squared is x to the first. You subtract 3 minus 2. And when you take an exponent of an exponent, or a power of a power, you multiply. So x squared cubed is x to the sixth. 2 times 3 is 6. And I will, 1, 2, 3. We added. 1, 2, 3. We subtracted. And then 1, 2, 3. We multiplied. This is important here. Not just like doing this for no reason. So when we multiply, we add. When we divide, we subtract. When we take an exponent of an exponent, we multiply. So this is basically all three of these properties right here. So the product property, so remember, and I keep emphasizing it, a logarithm is an exponent. The whole point of logarithms is to solve for exponents. So this is saying that if I have an exponent, and I'm a power basically, right? And I'm adding it to another power, it is the same thing as me multiplying it. So here is your MA of MADSEAM. MA. When I multiply, I add. This is basically the opposite, right? When I add, I multiply. It is the same thing. So what this means, as long as it has the same base, if I have the log of any base, so let's do blue again, example. Log base 7 of 10 plus log base 7, same base, of 8. It is the same thing as log base 7 of 8 times 10, which is 80. This is your example, ladies and gents. Let's do one more example. Or let's do the opposite, right? So how can I rewrite log? I'll just write, you know what I'm going to use? Because I haven't done it. The natural log, which again, the natural log from its review is the same thing as saying log base E. So natural log is log base E. So as long as I use natural log all across, they have the same base, right? B is E. So the natural log of 2x. How can I rewrite that as 2? How can I expand it essentially? Is equal to the natural log of 2 plus the natural log of x. Okay, quotient property, same concept. So here's the ds. When you divide, you subtract. Again, you're doing it backwards now. When I subtract, I divide. So if I have something like log base 7 of 3 minus log base 7 of 2, it is the same thing as saying log base 7 of 3 over 2. Or if I have natural log of 8, what is an example of writing this as two separate statements? So if I can make it log, just kidding, natural log of 16 minus natural log of 2. 16 over 2 is 8. Or it's also equal to natural log of 32 minus So it's important. When you subtract, you divide. And the last but not least is the power property. So this is the EEM of when you take an exponent of an exponent, you multiply. So here, this is the same thing right now. This is important here, is that log base b of m to the n is the same thing as saying log base b of m raised to the nth power. It's both, they're exactly the same thing, okay? This is saying I'm taking a power, right? Remember, logarithms are exponents. I'm taking an exponent and I'm raising it to an exponent, meaning an exponent raised to an exponent is the same thing as saying I am multiplying. You know what? Let me color code this a little bit better. This is an exponent raised to an exponent. So I'm taking this exponent and I'm going to multiply it by this exponent. Two exponents just being multiplied together. So what does that mean? I am taking this n and I'm practically just bringing it up front. So an example. If I have log base 8 of 3 squared, it is the same thing if I take this 2 and I bring it up front as saying it is equal to 2 times log base 8 of 2. Another example, if I have log base 4 of 4. Well, we know that's 1, but let's go with it. Or you know what, let's go with, let's do 16. Now we know that log base 4 of 16 is equal to 4 raised to the what power is 16 is 2. But let's see what happens if we actually use our exponent properties. Will we get 2 again? The answer should be yes, but let's see. Now, this is the same thing as me saying log base 4 of 4 squared, right? So if I take 2 and I bring it up here, right? So this 2 comes up here, I get 2. Well, let me write that here. 2 times log base 4 of 4. And by my identity, right, or my foundation property, log base 4 of 4 is the same thing as saying 1. I'm going to change that color here. This is the same thing as saying 1, and 2 times 1 is equal to 2. So no matter how you approach it, I could even, if I was being a little crazy, right, I could write this as log base 4. 16 is also the same thing as saying 2 to the 4th power. If I bring that up front, right, I bring this up front, I get 2 times log base 4 of 2. Log base 4 of 2. What can I raise 4 to get 2? It's taking the square root of it. So this is the same thing as 1/2. Right, 4 comes up here. And 4 times 1/2 is 4 times 1/2 is equal to 2. Either way, I get the same. So it's really important to understand all these properties in order to apply it. So just an example of applying more than one property in one problem. So expand log of xy over 2. Now, what's the base here? The base is going to be 10, right? If it's not there, it's assumed to be 10. So log of xy over 2. So these are being multiplied, meaning they're really being added. And then this is being divided, so it's really being subtracted, right? So it's log, you know what? Let's make this a little bit harder and put a 3 up here. So the first thing I'm going to do is I'm going to bring this 3 up here. And so this becomes a 3 times log of xy over 2. And I put it because this 3 is being multiplied by everything. So when I expand this 3 is kind of going to act like that GCF that stays on the outside. So I'll keep that here. Now I'm going to expand this. This is saying log of x plus log of y, right? That is your numerator, minus log of 2. Now, if you're given a problem, you know what? I'll even change this for a second, just so you can see how it would react when it's something that changes. So, like log of 10, what is log of 10? Log base 10 of 10 is 1. And you would have to simplify it if it is simplifiable. So this, my final answer is going to be 3 times log of x plus log of y minus